introduction. You use it every single day. From unlocking your phone with your face, to asking a voice assistant for the weather, to Netflix suggesting your next binge watch, to chatbots that answer your questions. We call it artificial intelligence, or AI. It seems to learn, to understand, sometimes even to create. But where did this idea come from? Did we discover a fundamental law of intelligence? Or did we invent a new way of thinking? The truth is, it's a bit of both. We are going to explore the journey from ancient dreams of intelligent automatons to the complex neural networks that power our world today. It's a story of philosophy, mathematics, and a profound human desire to build a mirror for our own minds. This is a story of how we tried to make machines think, and that is how we created artificial intelligence. Part 1. The Ancient Dream, the Why. Our journey to AI doesn't begin with computers. It starts thousands of years ago with a fundamental human question. Can we create life? Can we build something that thinks like us? Ancient Greek myths told of automatons, self-moving statues like Talos, a giant bronze man who guarded Crete. In the Middle Ages, legends spoke of golems brought to life. Fast forward to the 18th century, and elaborate clockwork figures like the writer or the musician amazed audiences by performing complex tasks. These weren't intelligent, of course. They were just intricate machines. But they represented humanity's enduring fascination with replicating intelligence. We wanted to understand ourselves by building something like ourselves. The true discovery that would one day lead to AI wasn't a piece of technology, but a way of thinking. It was logic. Philosophers like Aristotle developed systems to break down arguments into simple true, false statements. Later, mathematicians like George Boole in the 19th century created Boolean algebra, reducing all logical thought to ones and zeros. This was a critical step. If thought could be represented as simple binary operations, then maybe, just maybe, a machine could perform those operations. Part 2. The birth of the idea. Turing's vision. The real spark for AI, as we know it, came from a brilliant visionary mathematician during World War II, Alan Turing. While working to break the German Enigma code, Turing wasn't just building a machine to calculate. He was pondering a much deeper question. Can machines think? In 1950, Turing published a groundbreaking paper, Computing Machinery and Intelligence. In it, he proposed a test, now famous as the Turing test. He imagined a human conversing with two unseen entities, one a human, one a machine. If the human couldn't tell which was which, then the machine could be said to think. This was a profound discovery. Turing didn't just invent a machine. He helped discover the very idea of machine intelligence. He laid out the conceptual framework, the theoretical how, for thinking about machines that could simulate human thought. He showed that intelligence wasn't necessarily magic. It might just be a very, very complex series of logical steps. Part 3. The Invention. Early AI and the Summer of '56. With Turing's theoretical groundwork, the actual invention of AI began. The critical turning point was a summer workshop at Dartmouth College in 1956. This wasn't just a conference. It was a deliberate gathering of minds with a bold goal: to formally study artificial intelligence. The term itself was coined by one of the organizers, John McCarthy. At Dartmouth, pioneers like Marvin Minsky, John McCarthy, Claude Shannon, and Herbert Simon gathered. They didn't have powerful computers by today's standards, They were room-sized behemoths with less processing power than your doorbell. But they had big ideas. They invented the first AI programs, Logic Theorist, a program that could prove mathematical theorems. It was a machine reasoning for the first time. General problem solver, GPS, but not the navigation kind. Designed to solve a wide range of symbolic problems, mimicking human problem-solving steps. These were the first deliberate inventions aimed at making computers intelligent. They weren't just calculating. They were manipulating symbols, making decisions, and proving things. And that is how the field of artificial intelligence was born. Part 4. The AI Winters and the Rise of Machine Learning. The early optimism of the Dartmouth workshop soon faced harsh realities. Computers weren't powerful enough, and the problems were far more complex than anticipated. This led to the first AI winter, a period of reduced funding and skepticism. But the desire to build thinking machines never died. The next big invention came in the form of machine learning. Instead of explicitly programming every single rule, what if we could teach machines to learn from data just like humans do? The key breakthrough here was the neural network inspired by the human brain. First conceptualized in the 1940s, it truly took off in the 1980s with the invention of backpropagation, an algorithm that allowed neural networks to learn from their mistakes by adjusting the connections between their neurons. It was an invention that mimicked the brain's learning process. Suddenly, AI wasn't just following rules. It was pattern matching at an incredible scale. This led to breakthroughs in things like recognizing handwriting and speech. Part 5. The Data Revolution and Deep Learning. The real explosion of AI we see today came from two monumental shifts. Massive data. The internet, social media, and digital sensors generated unimaginable amounts of data. This was the fuel AI needed to learn. Computational power, graphics, processing units, GPUs, originally designed for video games, turned out to be perfect for the intense parallel processing needed for neural networks. These shifts enabled the invention of deep learning. Deep learning is just a type of neural network with many, many layers, hence deep. These deep networks could automatically learn incredibly complex patterns from raw data without human input on what to look for. This led to AI achieving superhuman performance in tasks like image recognition, identifying objects in photos, powering your phone's camera, and self-driving cars. Natural language processing, understanding and generating human language, leading to chatbots, language translation, and creative writing AIs. Game playing, AlphaGo, beating the world champion at the incredibly complex game of Go, a feat once thought decades away. Conclusion. So what have we truly done with AI? Did we discover intelligence or invent it? We didn't discover a magical formula for consciousness. Instead, we discovered how to formalize logic, how to represent patterns, and how to build systems that can learn. And then we invented incredibly sophisticated algorithms, data structures, and computational architectures that allow machines to perform tasks that, to us, look like thinking. From ancient dreams of automatons to Alan Turing's groundbreaking ideas to the sheer computational power and vast data of today, we have been on a continuous quest to extend the capabilities of the human mind through technology. Today, AI is not just a tool. It is becoming an active participant in our world. It writes, it paints, it drives, it diagnoses. The future of this invention is still being written, by us, and increasingly by the very intelligences we have created. And that is how we taught machines to think.